Hello, Dr. Padma, and hello, everyone. I want to present the AI Square OT midterm project. My name is Sukma.meganova FND. I'm a doctoral student in Rajamangala University of Technology, Tanyapuri. The topic of this project is about embedded systems and Internet of Things using ESP32, DHT22, and LED. The outcome of this project is a system that integrates and communicates between the electronic system and Internet of Things (IoT) system and vice versa to control alarm using LED in two different states, on and off, and also display the humidity and temperature value using the ST22 sensor. There are two pictures in this slide. In the left picture is about the IoT system using Finger.io platform. And then in the right picture, this is the circuit of the electronic system or the embedded system. This is the hardware that used for the electronic system or embedded system. The first is the ESP3230 pin, and then protoboard, LED, resistor 330 ohm, the ST22 sensor, jumper, and micro USB cable. This is the wiring diagram of the embedded system or electronic system. In the ESP32, I use pin D14, pin ground, pin 3.34, and another pin ground, and then pin D2 and pin D4. And the ESP32 connected to the hardware. The hardware is the DHT22 sensor and circuit of resistor plus LED. The pin D14 wired to the serial circuit of resistor and anode of LED. Pin ground wired to the cathode of LED. Pin 3.34 wired to the pin VCC of all the DHT22 sensor. Another pin ground wired to the pin ground of all DHT22. And then pin D2 wired to pin out of the DHT22 as sensor 2, and pin D4 wired to the pin out of the DHT22 as sensor 1. This is the concept of the system. In the system, we have basic flow diagram that consists of input, process, and output. In this embedded system and IoT, we also have input as a publisher or similar to transmitter, and then the process for transmitting the data or signal, and then the output as subscriber or similar to receiver. Publisher as input, MQTT broker as process, and subscriber as output. This image illustrates the architecture of an MQTT, message queuing telemetry transport, communication system of this project. Publisher of the LED system. The LED system is LED switch in the dashboard, and the subscriber of the LED system is active high LED circuit in the embedded system ESP32. And then the publisher of the ST22 sensor system is the sensor in the embedded system ESP32. And then the subscriber is display monitoring value of sensor measurement such as temperature and humidity in the dashboard. Publisher will collect the data of the ST22 sensor in the embedded system ESP32 such as temperature and humidity, and also collect the signal control of LED switch in the dashboard, then send the data to the gateway, and publishing the data to MQTT broker. Send the data to the MQTT broker. It publishes the data under the topic. After that, MQTT broker receive the data from publisher, and distribute to subscriber, and then the broker manage the topic. And ensures that data published into a specific topic is delivered to all subscribers interested in that topic. In the subscriber side, it is also having a gateway that receives data from MQTT broker, and it subscribes to the topic to receive the data. After the data is received, it is distributed to various components for further processing. The DHT22 sensor shows real-time monitoring system in dashboard. And the LED, it shows the received signal in two states, on and off the LED circuit in the ESP32. In this slide, also illustrate the concept in the real-time embedded system ESP32. This is the circuit, and then this is the process using MQTT broker Tinger.io, and then this is the dashboard. And then the software that used in this system, the first is Arduino IDE version 2.3.2. And in this Arduino IDE, we have to add the library of ESP32 because the device is using ESP32. The name of the library in the code is Tinger ESP32.8. There are three ways to add the library of ESP32. The first, open the Arduino IDE and then go to the Tools menu and then choose Board and then choose Board Manager and then write ESP32, and then after the library shows, and then click Install button. And then the second, just click the icon of Board Manager in the left tab icon, write ESP32 after the library shows, and then click the install button. And then the third way is go to the file menu and then choose preference and then choose the setting and go to the additional board manager URLs like this in the picture, and then copy and paste this link to the additional board manager URL, and then click OK button. And we have to wait until the installation of ESP library ESP32 is done. And then the second software is the Thinger.io. This is the link. Before we run the system, we have to make a pre-communication. This is for Wi-Fi setting. In this picture, shows that the computer already connected to the Wi-Fi. This is the Wi-Fi of my phone, from my phone. I already connected. And ensure that in the code, in the Arduino, the SSID and password is the right name and the right password. And also ensure the username, device ID, device credential in the Thinger.io platform. After that, ensure that the device, the electronic system, already connected to the Wi-Fi on the phone. Open the settings and then go to the portable hotspot and then find the connected device, and then ensure that the device, in this case is ESP32, is connected in the Wi-Fi in the phone. After the device is connected to the Wi-Fi, we have to make the dashboard. So I open the Thinger.io platform. Write the username and the password, and then click the login button, like in this picture. And then after that, the Thinger.io menu is open. Go to the device menu, and you can see the device that already connect or online in this Thinger.io by looking the circle symbol in this name is green. If the circle icon is red, it means that the device is not connected. And then just click the name of the device, and then after that ensure that the device is online by looking this in green color, and then go to the menu API to ensure the value of sensor and also the control for the lab is already established in the Thinger.io. This is the first data. This is the first data for humidity DHT1. This is sensor 1. This is the value. And then this is the second value of humidity DHT sensor 2. And then this is the LED control using switch. Data type is Boolean. You can click turn on and turn off to control the lamp, to control the LED. And then this is the value of the temperature DST sensor 1, and this is the value of the temperature DST sensor 2. If the value is shown in this API Finger.io, it means that the device is work. And then after that, we have to make the dashboard. Just go to the dashboard menu and then add dashboard. Click the add dashboard and then fill the name and so on. And then after the dashboard name for the system is shown, just click the name of the dashboard and then it's still empty, and then go to the menu plus app widget, and I will show this is the dashboard that I use in this system. This is LED, this is temperature sensor 1, temperature sensor 2, humidity sensor 1, and humidity sensor 2. You want to make the dashboard like this. The LED is using switch, temperature sensor 1 using donut chart, also the temperature sensor 2, and then for the humidity sensor 1 and humidity sensor 2, the display is used tactometer. This is how to make the dashboard for LED. So first, after click the plus add widget, and then choose the window of widget setting. There are widget menu, and then in the widget menu, we have to write the name of the LED dashboard, and then choose the link to the dashboard name, and then choose the color of the dashboard background, and then choose the type of the dashboard for LED. This is on or off state. This is the name of the dashboard. This is the color that I choose. And then after that, go to the on-off state menu, select the device, choose the right device system, choose the device name, and then choose the select resource. In this case is LED, and then go to the display option menu, choose the switch style. The switch style is switch, and after that just click the save button, and then the dashboard for LED is shows like this. You can adjust the display of the LED dashboard. And then this is for making the dashboard of temperature sensor 1. Also the same way, click the add widget, and then in the widget menu, write a specific name and then link to the dashboard name, and then choose the background color, and then choose the type for temperature. The type is donut chart, and then after choose the color and the type, and then go to the donut chart menu, select the device, choose the right device name, and then go to the select resource, choose the right resource. This is for temperature DHT sensor 1, and then adjust the sampling interval. This is setting in 1 second. It means it will be updated every 1 second. And then go to the display option menu. In the unit, we have to write the unit for temperature. It's degree Celsius. And after that, just click Save button. And after that, the display of temperature DHT sensor 1 is shows like this. And for the temperature sensor 2, have the same ways like making the dashboard for temperature sensor 1. Just write the specific name for DHT sensor 2 and then choose the right dashboard name in the link tool. Choose different color of the background and then choose the type donut chart, and then in the donut chart choose select the device name and then choose write result temperature DHT2, and also in the display of, and there is a sampling interval just set in 1 second, and then in the display option also write the unit degrees Celsius, and this is the display of temperature DHT sensor 2. And after that, make the dashboard of humidity sensor 1. The first is go to the widget menu, write the specific name humidity DHT1, and then link to the right dashboard name, and then choose the different color with the temperature, and then go to the type, choose the tachometer type, and then go to the tachometer menu, choose the device name, write device name, and then choose the resource. The right resource is humidity sensor 1, and then set the sampling interval in 1 minute. It means update for every 1 minute. And in the display options, we have to set the minimum range value 0, and then the maximum range value is 100. After that, click the Save button, and then this is the display of humidity DHT sensor 1. So for the dashboard of humidity sensor 2, this is the same way. Just write the specific name, choose different color, choose the right type, and also choose the right link to dashboard name, and then go to the tachometer menu, choose the right device name, select the right resource humidity DHT2, set the sampling interval in 1 minute, then set the range value in the display option from 0 to 100, and after that click the Save button, and this is the display of humidity DHT sensor 2. I will explain the code in the Arduino IDE. Okay, this is the code in the Arduino IDE. I use two libraries in this system, Thinger ESP32.h and DHT.h. The Thinger I/O platform, an Internet of Things platform that facilitates simple device management, can be accessed by the ESP32 through this Thinger ESP32.h library. And the DHT22 sensor, which measures humidity and temperature, can be interfaced with this DHT.h library. And then in this part is for define credentials and Wi-Fi details. You have to write the Tinger.io username, and then Tinger.io device ID that used for identify the specific ESP32, and also the device credential. Just write the same name for as device ID. And device credential, this is for authentication on the Tinger.io platform. And in this part, this is for defines the Wi-Fi network SSID name and password, Wi-Fi password, which is the ESP connection point. And then in this line, this is for initializing our ESP32 object name using thing, which will handle the connection to the Tinger.io using the provided credential. And in this part, this is for 2DSC22 sensor configuration. In this in the ESP32, the pin 4 is defined for TST sensor 1, and then pin T2 is defined for TST sensor 2. And this is the type of the this is the type of the TST22. This is the type of the sensor. And then in this part, this is for initialize the THT object to interface with the two THT sensors. The object name is TST1 and TST2. TST1 for sensor 1, TST2 for sensor 2. And then this is setup function. The first is initialize serial communication for debugging purpose. The baud rate in this system is used 100 and 115,115 And then this line, pin mode 14, this is configured the GPIO or pin D14 as an output pin. This is used for controlling the LED circuit. And this line is for connect the ESP32 to specified Wi-Fi network. And in this part, this is for initialize the two DST sensor. And then in this line, this is for connect the Tinger.io resource LED to GPIO pin 14, which enables remote control of the LED attached to this pin. And then in this part, this is for register a resource on Tinger.io to transmit the TST22 sensor, TST22 sensor 1's temperature measurement. In this variable T1 for temperature TST sensor 1 using data type float. This is because the sensor shows giving the output of analog value. Analog value is in fraction number, so we have to use the float data type. And then this is the instruction for shows the value in the serial monitor in the Arduino IDE. And then this is the part for register a resource on Tinger IO to transmit the TST22 sensor 1 humidity measurement. So this is for the humidity sensor, humidity DHT sensor 1. The data type of the sensor value also is float. And then in this part, this is like in the temperature DHT sensor 1. So this is the code for register a resource on Tinger.io to transmit the DHT sensor to temperature measurement. And in this part, this is for register a resource on Tinger.io to transmit the DHT sensor to humidity measurement. And the last, this is the loop function. Only two lines, thing.handle. This function keeps a connection to Tinger.io active, ensuring data is sent and received properly. And the last is delay 100. This means introduce a short delay of 100 milliseconds between iteration of the loop. And I will show the experiment. This is the experiment that I made. This is the first preparing the communication, connect to the Wi-Fi on my phone, and also ensure the username, device ID, device credential in the Tinger.io. And then this is to ensure the SSID and password of my Wi-Fi in the phone. And then connecting the ASP32 by choose the port and then choose the right port or port detected in this computer. And then after that, upload and wait until done, and then go to the Tinger.io. This is already login into the Tinger.io. This is the electronic system, the embedded system. This is the ESP, this is a LED circuit, and this is the 2 DST22 sensor. This is the wire. And then in the Tinger.io, go to the device, go to or choose the device that detected in the green color and online tag, and then go to the API and check if the device already sent the data. And this is for humidity DHT sensor 1. DHT sensor 1 is using pin T4. DHT sensor 2 is using pin T2. And then I check if the data is already sent to the Tinger.io to the dashboard. The value is updated, is changed. So the first DST22 sensor is already worked. And then the second sensor I click the humidity DST sensor 2 and then click the run button, and then the value is updated. So the DST sensor 2 also work. And this is for controlling the LED, just using the switch. If I click turn on, the green color change in green color, the LED will be on. And after I click again, it changes into white color, the LED is off. And this is for checking the temperature of the SD sensor 1. I also click the run button, and the value also changed. It means the THD sensor 1 is work, and also the temperature THD sensor 2. I also click the run button. It will be, and it's update. So the temperature THD sensor 2 also work. And after that, go to the dashboard. Click the name that I already made, and this is the dashboard display. This is for controlling the LED, for temperature the SD sensor 1. The LED, when I click the switch, in the change in the green will be on, in the I click again, in the white color will be on. I will show again. Click until the green color will be on the LED, and then I click again, change to the white color, and the LED is on. And this is for the temperature DSC sensor 1. This is for temperature DSC sensor 2. This is for humidity DSC sensor 1, and this is for humidity DSC sensor 2. Okay, that I can show for my project or midterm project of the AI squared OT project. And thank you for watching this video.